very live.
Brilliant. So I'm going to talk to you about serverless tile services in the cloud, and this is an extension of a lightning talk that I gave at Fossil G in Florence. But since then, we've been working quite hard on this, and some really new bits of, some new data formats supported, and some new tech that we've put in there to do that, and I think it's quite innovative. So a little bit of a background. Mark sort of talked about this before, but some numbers to say about who we are. So Addresscloud. Underpinning a large insurance market. We do 75 million transactions a month. Most of them are sub-half seconds, so we're very much focused on scalability, robustness, and reliability. Thanks, mate. But one of the things that we haven't talked about traditionally, we talked about lots of architecture stuff, and we'll get into that. But one of the things we haven't really talked about is actually our map users. So we've got 2 applications now and a third one in development, and they're client-side applications that allow people to look at maps of locations, properties typically. So put an address in and tell me about it, and then we have lots of data inside those maps, like JVA flood scores or subsidence or crime scores. And so with these 2 applications now, as the business is growing, I looked in our authorization tool and saw there are actually 1,600 uses of the map tools just in the last 7 days. So actually got a lot of people looking at a map to access Addresscloud, as well as all of those API transactions coming along. So that's really the context for this talk. We use vector tiles predominantly to render lots of different types of data on those maps. So we've got our base map that shows you something like this, which is OS Open Loop Stack. But then we've got layers on top of that that maybe show a flood risk or a crime risk. Previously, to take that geographic data that typically sits in our PostGIS database, which is our kind of data warehouse, we'd push that out as a series of vector tiles, and we'd upload them into a bucket inside Amazon, and then in front of that bucket, we'd couple it to what's called a content delivery network, which is just a fancy name for a service that says, I've got some stuff, please put it on the internet. And by that, it gets distributed to all different places around the world. And we use AWS CloudFront CDN, which is a service from AWS to do that, but others are available. And it's really, really good. And Mark wrote a really good presentation and actually tutorial of how to do this. He presented at a FOSS event in Tanzania back in 2018, I think, and it's there, linked to the GitHub. And so it's a really good way, if you've got tiles that you're happy to be publicly available, it's a really good way to make your vector tiles available to your web application client. Now, the biggest caveat that if you want to secure those tiles, if you want to have some authorization mechanism that stops people accessing those maps or those map layers when you don't want them to, then you have to use cookies. And we found that cookies are particularly sticky for our front-end applications because we weren't using a cookie-based authentication scheme. So we had to build our own kind of custom authorizer stuff to like exchange a token for a cookie, and we were just using it for this one thing, which was rendering our map tiles. And then I think it was last year, the latest version of Chrome introduced some stuff that made it even harder to use cookies when you're working and developing on localhost, and actually watching our web developers developing on localhost, trying to build a map application, but they weren't able to render any map tiles. I was like, oh man, we've got to fix this. Like this is priority 1 for me. So I went away and beavered away in the summer to build a solution. So what did we build? We built something that's really simple, conceptually simple, complex under the hood. We used Amazon API Gateway, which Dave has already introduced. It's a service provided by Amazon that sits there and listens for API requests. Cool. So there's some servers there somewhere, but I don't care about them. I don't even know how many there are or what they're doing. And then in this instance behind it, it's just an S3 bucket, so a data store. There's no code here. So this is a service that has there's no like logic, there's no JavaScript, there's no Python, there's no anything else. It's just forwarding requests from API Gateway to our S3 bucket. And I'll talk about how that's possible in a second. And just to recap why we did it, is because we've got these tiles that we need to get to our users that have logged into our authenticated application, but we need to protect them. We need it to be serverless because we need it to operate at scale, because apparently now we've got lots of people looking at maps all the time. And we also wanted to standardize our APIs, because that was really the problem, is that we had this other kind of weird cookie thing going on. We could have invested more time in that, but it was one kind of niche. So it's really all about standardizing our APIs to improve our developer experience to help bring our new applications to market faster and with greater ease. So how does it work? A client makes a request using what's called the Slippy tile specification. So the Slippy tile spec has been around for quite a long time. It's available on an open license. It's documented by OpenStreetMap. So you say, this is my zoom level, this is my X coordinate, this is my Y coordinate. Please give me the appropriate tile, and the tile being a perfect square of some representation of stuff, of geographic stuff on the Earth's surface. It forwards the API gateway listens for that request and forwards it to S3 because S3 understands HTTP requests. So it's not just a data store, it's also a web server. And that's really nice because it means that we can say, hey, I want this particular file based on its ZXY file name. Please go get it for me, and then that's returned. And the thing that I've added more recently is a scene that there's, as well as having lots of little files, which has been a very traditional way of having a suite of tiles, is you'd have a process to take your geographic data and chop it into lots of small tiles, and you'd put them on a server somewhere. There's also this new emerging couple of standards around tile files, where you have one file, and you can access a small subset of that file using a range request. You say, hey, I only want this section of the file because that's the tile that I want. And the vector tile spec for that is a new format called PM tiles that I learned about PostGIS International this year. And that's like, I've got this vector tile file, but it's just one file on disk, but I can query it using a web server. The raster equivalent is a cloud-optimized geotiff, which Dave has already talked about, and has been around for a few years now. And you can say, I want this handful of pixels, but what you can say is, I want this handful of pixels, and I want them to represent a tile in my client application, kind of. So we've published this module as a bit of open source kit that anyone can get and use, and there are two kind of endpoints that support these two formats. So we've got tile sets where I say, hey, I've got lots of small files representing vector data or lots of small files representing raster data, and I tie those together using a tile JSON spec, which is a specification I think it was published by Mapbox originally, but it's now an open standard for having tile-specific vector tiles and raster tiles. And then tile files where I've got this one big buying file, and I want to say I want only a little bit of that file at any one time. Checking my time. So API Gateway gives us a lot. It's basically doing a lot of the heavy lifting here, if not all of it, because it's forwarding those requests to S3. It's protecting S3 from public access. It's keeping the bad guys out and letting people in. It's got caching enabled, so you just click the button, some service happens somewhere, and then there's that really fast caching, so you don't even have to go to the bucket. It does edge deployment, so it gets that CloudFront CDN stuff back in because there's an integration and AWS is doing the magic. And as I already said, there's no like compute here, there's no code, it's just connecting stuff together. I've packaged this as a Terraform module, which is our what we call an infrastructure as code tool to say, hey, I want to stand up some infrastructure in AWS. Terraform is one such tool that does that. So you can either grab that module and run with it, or you can at least interrogate that module and understand, hopefully, how we've done what we've done. And I'm going to show some examples of this, but one of the other bonus features that's really interesting is API Gateway supports what's called the velocity template language, which means you can interrogate and modify your requests as they come in. And so you can start to change those requests to say, actually, I want to point to a different deployment of those tiles. If you've got different versions, which is kind of what Mark was alluding to, we've got different versions of files, but maybe I want to show like one customer the old version of the flood map, and I want to show another customer a new version. I can start to support versioning, but I can make that, I can basically reroute that, think of it as like a routing element, reroute that request on the fly using this template. So there's some resources. I'm going to grab this chair, sit down for a second. So it'll be much easier to drive. So appreciate the screen is a little bit small, but if you head over to github.com/addresscloud, and this work is all published under Terraform AWS tile service. So I've published this on the Terraform registry for those of you, if there's anyone in the room that's using Terraform, and there are some nice examples in here. So for example, enabling caching. This is how to configure the module to enable that caching layer. But perhaps, and maybe of more interest to this room, is actually in the repository as well. There we can see the API. So it's a pretty simple API. It's basically, do I want a tile set or do I want a tile file? And if it's a tile set, then I specify the version and the ZXY, and the version is simply a folder in an FC bucket. If it's a tile file, it's just pointing at a particular file, so saying here's my cog or here's my PM tiles file. And then what's really nice is I've also published 4 client demos that we can take a look at now, and I'll talk you through. So the first one, and this is probably going to look most familiar to people, is a vector tiles service. So we've got I've downloaded OpenStreetMap data, I've made loads of vector tiles of it. I've put them in a bucket, and then I've got this is MapLibra, which is a fork of the Mapbox front end, and I'm saying, okay, make requests for these vector tiles. And as I zoom in, we should see the network tab going off and getting all these little PDF files, and they're being rendered on screen. And take no credit for the awesome cartography. Props to the map tiler guys. You know, start to do crazy things where it's like in 3D. But the point being that we've put these in a bucket, but we're routing our requests through API Gateway, and we're using this in our applications. So that's nice. I've got a raster version. Actually, we can see the source. I've linked to the source code, so you can see the source code for all of these as well. So you can see here's my request. It's pretty simple, a very simple HTML file. I just got to add a little transform to add in my API key, which we've got a demo API key for this purpose. And I'm just saying, okay, if you're hitting this API, then add this API key in. You can do lots more advanced authentication as well with API Gateway, which is really nice custom stuff. But here we're just using API key. So that's nice and simple. That's the idea. And here we've got a raster equivalent, I think, with a Sentinel image. So I grabbed a Sentinel image for Florence. I chopped it up using QGIS into lots of small tiles again. And if we look at the network requests as we zoom in, it should actually be able to see, you can see the little images coming back. And then the client is stitching together those little images. So nothing really new here. All we've done is taken existing open specs, Slippy map tiles, and we've supported it inside API Gateway. Where it starts to get really interesting, I think, is the support for these 2 new formats. And PM tiles is definitely the one I think that's most interesting. So now, instead, what we've got is basically the same geographic data set, but I've converted it to a PM tiles file. So I've got one file in a bucket. And if you see the requests, the network requests as we zoom in and out, I'm now actually just asking for the same file over and over again. But each time I'm just asking for a little bit of it. I don't take any credit for the PM tiles technology. That's Proton Maps. It's definitely worth a Google. I've got a link at the end of the presentation. And the source code shows that we use this extension, which is an extension from MapLibra called the PM tiles protocol. And that basically translates from Slippy map tile spec in the client, so ZXY coordinates, into the range requests that you need for that tile file. It's super clever stuff. And I'm just taking open source components that are already there and bolting them together for the purposes of this demo to show that basically we can serve out any kind of binary format that's got geographic data in it using API Gateway and S3. And so, that's the range requests for the same, and the tile set looks pretty similar. I didn't render all of the zoom levels just for the file size. Be interesting to see how that performs at scale. And then the last one is COG. Now, cloud optimized geotiffs, something that's close to my heart. I love them. I think it's an amazing spec. There isn't a great way currently to render a tile from a COG in a web client. The GeoTIFF.js guys have done a lot of work in this space, but it's still pretty basic. I'm interested if anyone has looked at doing this, because it's render the whole image in one go. What we're actually doing here is we're saying, I can't access a handful of pixels and get them back as a tile, which would be ideal. But what we're actually saying is our COG standard has got something called overviews in, where we've got a big raster image on disk, the same Sentinel image, which was maybe a couple of 100 megabytes off the top of my head. And we've built some overviews of that are stored in that same file. And here we're asking for that overview. So we've said that the total download size is going to be a couple of megabytes, and then we can render that on the screen. And you start to see people like NASA using this quite a lot in their Sentinel archive now. When you see the thumbnails of the images, they're starting to back onto COGS, which is really cool. So those are my 4 demos, and I think we're actually running ahead of time, which is really nice. But I'm going to leave it there and just come back to the slides. So this talk, I'll pop it in the repo with the other talks that are in there, and the code's there, so you can get going. There's a link there to the previous work. If you've got public data that doesn't need to be protected by API Gateway, if you don't need API Gateway, then definitely look at the CDN route. It's like fast and cheap and amazing. So I would recommend that route if you haven't got the kind of additional security burden of having private data requirements. And then totally take a look at this blog on PM tiles. It's really interesting. The blog post starts, if it loads, with the concept of a raster image that's actually a video. So it's pretty out there in terms of what people are starting to do with different data formats. And that's it. Thanks for listening. Cheers. And I'll take questions if there are any.
Yeah. So does it follow ODC standards? Because you're reading it in a map viewer, right?
Yeah.
Yeah.
So I don't know if the Slippy spec is an ODC standard. It's an open standard. I don't know if it's part of ODC or not.
Okay.
But it's a defined standard. MapLibra, Mapbox, OpenLayers, like they all support Leaflet. They all support Slippy map tile spec. And this is we're using. And then a lot of them also support that tile JSON spec, which is kind of an addition to that, where say I've got this collection of small tiles. You have a tile JSON file that basically ties that together and has attribution, zoom levels, and that kind of thing in. That's all work that Mapbox did back in sort of the late 2000s.
Very cool.
Great. Everyone's ready for coffee. That's good. So we're on coffee break until half past?
Half past, yeah.
Half past. And then we've got Mike's presentation and then the final keynote. And then